Namaste. Welcome to the session. It's continuation to previous class. We discussed previous questions in circles. Today also, let us see some more previous questions, and then wherever necessary, we'll be revising the concepts related to this. Okay, now here if you see continuation to previous questions. This question 2019 May 11th January, the straight line x plus 2y is equal to 1 meets the coordinate axis at A and B. A circle is drawn through A and B, AB and the origin. Then the sum of the perpendicular distances from AB on the tangent to the circle at the origin. So whenever there is a point to be revised here, a circle is passing through 0, 0, A 0, 0 B. I repeat, 0, 0, A 0, 0 B. Then the equation of the circle is x squared plus y squared minus ax minus by equal to 0. This everyone must know. So here also the same case, what he is discussing about. The straight line x plus 2y is equal to 1 meets the coordinate axis at A and B. What is the line equation? X plus 2y is equal to 1. Let us see that. X plus 2y is equal to 1 is the line in the intercept form x by 1 plus y by 1 by 2 equal to 1. That is the intercept form of the line equation. Now the circle is passing through the origin and making an intercept of 1 unit here. This goes like this. This is the circle. This is A. What is A there? 1, 0. What is B? 0, 1 by 2. The circle is passing through this. Then this is 0, 0. The equation of the circle will be x square plus y square, just now I said, minus ax minus by equal to 0. That is the equation of the circle. Now, what is the question there? Then the sum of the perpendicular distance from A and B on the tangents to the circle at the origin. That means at the origin a tangent is drawn. This is the tangent. From this one the perpendicular distance is to be found out. From this one also the perpendicular distance is to be found out. The sum of these two perpendicular distances is needed here. So here, what is that to be understood? The tangent at 0, 0 is S1 equal to 0, please. S1 equal to 0. So S1 equal to 0, if you apply 0, 0 minus 1 by 2 into x minus 1 by 4 into y plus 0 is equal to 0. So the tangent equation of the tangent is 2x plus y equal to 0. 4 is LCM, 2x plus y is equal to 0 is the equation of the tangent. Now perpendicular distance from, let me say this is AP, let me say this is BQ. So AP plus BQ is equal to, what is AP? Perpendicular distance from 1, 0 to this one, 2 by root 5. Perpendicular distance from 0, 1 by 2 to this one, 0, 1 by 2, root 5. So it is 3 by 2 root 5 LCM. So 4 plus 1, 5 by 2 root 5. So your answer must be root 5 by 2. Just check the options. root 5 by 2, option D. Option D there. Okay? Unlike the physical class, online class, if you do not understand, you can go back and you can rewind the video and you can see that. That's why I'm not repeating this. Anyway, the concept that is to be revised with regards to this problem. What we are doing now, we are taking a particular problem, and in that particular problem, what are the concepts that are to be revised in and around, we'll be discussing that. In that case, in the previous class also I told you that a circle passing through 0, 0, A0, 0B, AB. 4 points are there, concentric. The equation of the circle will be x square plus y square minus x minus by equal to 0. So all these 4 points are concentric. The problem is based on that only. Next one, let us see. Next one. It is, if a circle is passing through the point 4, 0, touches the circle, x square plus y square plus 4x minus 6y is equal to 12 externally at the point 1, minus 1. Then the radius of circle C is. See, the question, of course, understanding the question and applying the algebra. What I mean to say by algebra, coordinate geometry is nothing but plane geometry plus algebra. Without converting the given data to algebraic form, you cannot solve the problem. What does it mean by algebraic form? Converting it to x and y terms. That's what we have to do now. Circle C is passing through the point 4, 0, touches the circle. What is the circle given? X square plus y square. Plus 4x minus 6y. Minus 12 equal to 0. Center is equal to minus 2, 3. Whether it is necessary or not, let us think over. 4 plus 9, 13 plus 12, it is 5. Radius is 5. Now, a circle C passing through the point and touching this circle externally. This is a circle. It is touching this circle external. What is the point given? Point is given to be 1, minus 1. And let me say this as C1 please, because he used the alphabet C there to represent the circle. Now, what is the center of the circle here? Minus 2, 3. Where is it touching the other circle? At 1, minus 1. At 1, minus 1. Okay. Now, it is also an important point to be remembered, the system of circles here. The system of circles. See, when you take the case of system of circles, in the system of circles, there will be a circle which is a member of the system whose radius is 0. Don't forget that. Whose radius is 0. Like what? Like how? This is one circle, another circle. These two are touching at this point. So, this is a system for which this is also a member. Which one is a member? The point circle is also a member. So now, if you want the system of circles equation, if you want the system of circles equation, you can make use of this circle equation, or you can make use of this circle equation. But what we need extra is that we need the common tangent here. We need the common tangent here. So common tangent can be comfortably drawn here because it is clearly given that it is passing through, they are touching at 1 comma minus 1. So let me say this as yes, please. Now L is S1 at 1 comma minus 1. What does it mean? Equation of the tangent I am writing to the circle. At what point? 1 comma minus 1. Let us write that. Xx1 is equal to 0, of course. Xx1, x plus y by 1 minus y plus twice of x plus x1 minus thrice of y minus 1 minus 12 equal to 0. Everyone must know how to write the equation of the tangent using the formula S1 equal to 0. But remember, S1 equal to 0 is the formula to be applied only when the point lies on the curve. Only when the point lies on the curve. If the point is outside the curve, if the point is outside the curve, you're saying option A, na? That's correct, all. Good evening, Varshit, and good evening, Arun. So, here, point, this is a circle, this is a point outside, then you should not apply S1 equal to 0. If the point lies on the circle or on the curve, then only you have to apply S1 equal to 0. Now, this is the tangent to 3x minus y minus 4y plus 2 plus 3 plus 5 minus 12 minus 7 equal to 0, which is nothing but L, please. Therefore, system is S plus lambda L equal to 0. What is S there? X square plus y square plus 4x minus 6y minus 12 plus lambda into 3x minus 4y minus 7 equal to 0. But this circle passes through. What is the point given in the question? It is the required circle is passing through 4 comma 0. Substitute here 4 0 16 plus 16 minus 0 minus 12 plus lambda into 12 minus 7 equal to 0 implies lambda is equal to, it is 20, it is 12 minus 7 is 8, 12 minus 1, 5 there, minus 20 by 5, this is minus 4. So put lambda minus 4 here, put lambda minus 4 here, then what is the required circle? Your C is nothing but x square plus y square minus 12 plus 4 minus 8x, this is plus 16 minus 6y plus 10y, and it is plus 28 minus 12, plus 28 minus 12 is 16. Therefore, radius is equal to root over g square plus f square minus c. Answer 5 units. You're right, Sai Varshit. You answered it. It is 5 units is the radius. Just see how the question is formed there. It is purely, the question is purely formed on the system of circles, which is there here. S plus lambda equal to 0, lambda L equal to 0. The very important point with regards to the system of circles is that, the very important point with regards to the system of circles is that you have to understand that the system of circles, you must, if you want to write the system of circles, you must know a member of the system, number 1. And you must know the common tangent or common chord or the radical axis. Radical axis case is not in JEE. It's not there in JEE. So to write the system, you need a member of the system, or you need two members of the system. Even if you know two members also, if you subtract one from the other, you will get the common chord or common tangent. Here, the common tangent is indirectly given, so we wrote the common tangent. The circle is already there. We applied s plus lambda L equal to 0. But to get the required circle, you must have an extra condition. To get the required circle, you must have an extra condition. What is the extra condition given here? It is passing through 4, 0. It is passing through 4, 0, and hence we substituted 4, 0, and thereby we got lambda. That means we are getting a particular circle in the system. That particular circle, we have got it to be this one, and its radius we counted. Its radius we counted. That's it, please. Let us go to the next question. Next one. If the tangent at 1,7 to the curve x squared equal to y minus 6 touches the circle, then the value of C is. Simple question only. Simple question only. Sometimes, if you are getting this type of questions, you will be comfortable. But some questions I have seen, it is very time-taking. Time-taking, if you hang on to that particular problem, a lot of time will be wasted. So you have to decide while writing the examination. First of all, what you have to do, you have to go through the entire questions. There is every facility to, you can scroll and see. If all the subjects are seen, then whatever the subject you feel easy, start with that one. Start with that one. In all the 90 questions, nowadays it is only 75 questions. In all the 75 questions, whatever the questions you feel easy, first of all, write them. First of all, write them. It will boost up your confidence levels. It will boost up your confidence levels. And then you attempt the remaining questions that may be 50-50 or that may be 75-25, whatever. Then that confidence levels, when it is boosted up, the remaining questions can also be solved easily. So never start with the difficult questions. Difficult questions. Your morale will be will go down. That is the reason why. First of all, always answer easy level questions, then go for the remaining questions. So it can be decided. It can be decided. Shri Rama Subbareddy garu namaskaram andi. By using tangency condition, we can do. Option A. Good evening, sir. So this is tangent is 1,7. The condition for tangency R is equal to D. The perpendicular distance from center to the line is equal to radius. So what is here also the tangent formula? S1 equal to 0 is to be applied. Apply S1 equal to 0 to the parabola. Apply S1 equal to 0 to the parabola, please. What is the parabola given? Y square is equal to x square is equal to y minus 6. And what is the point given? 1,7. S1 at 1,7 is equal to 0, which implies xx1 minus 1 by 2 into y plus 7 plus 6 equal to 0, which implies 2x minus y minus 7 plus 12 minus 7 plus 12 plus 5 equal to 0. That is a tangent we have got. And it is given that that tangent is touching the circle. So perpendicular distance from center minus 8 minus 6 is equal to radius What is the radius here? 8 square plus 6 square, 100 minus c. So perpendicular distance minus 16 plus 6 minus 10 plus 5, 5 by root 5 is equal to root over 100 minus c, square it. 5 is equal to 100 minus c is equal to 95. Is it not 95? Sai Barshid answered it as option C. Ramasubbareddy answered it option A. Yeah, I too got option A only. No, not option A, option D I have got, C 95. Just check it out, please. Is it about the previous problem or this problem? The previous problem, this is 5 units, no? Okay. This is 5 units. Maybe that answer for the previous problem. Okay. So this is what you have to understand. This is a simple question. So the concept to be revised is the condition for tangency. I'm not simply discussing all the previous questions, only previous questions or otherwise. I am discussing the concepts in and around the question. In and around the question. So in this context, what I'm doing, I'd like to give you the different tangential conditions for circle, parabola, ellipse and hyperbola. For circle, parabola, ellipse and hyperbola. See, most generally, what happens if you take a line y is equal to mx plus c? If you take a line y is equal to mx plus c, okay, it is the most general line we use. It is the most general line. It's okay. Psi option is D. Correct. It's the most general line we use in every derivation of circle, parabola, ellipse, and hyperbola. And there are limitations for that line. What are the limitations? What are the limitations? Y is equal to mx plus c represents a non-vertical line. Y is equal to mx plus c represents a non-vertical line. For example, to find out the equation of any line means in this case common tangent. If you consider the common tangent as y is equal to mx plus c, and if you are solving the problem, if the common tangent is a vertical line, then you don't get the answer. The reason is, you have to take this line only when you know that the required line or the line to be solved is a non-vertical line. So, there you will get a clash. But why this is preferred by the mathematician? It is clearly only two unknowns are seen, c and m. If you take the standard form to the equation of a straight line, what happens? Ax plus by plus c equal to 0. You may be thinking that there are three unknowns, a, b and c. But there are not three unknowns there. There are not three unknowns. For a line, only two unknowns will be there. So, to solve the vertical lines, what we do, we take the line in the form of px plus qy is equal to 1. Or take the line in the form of lx plus my is equal to 1. Or take the form of the line as ax plus by is equal to 1. You can make that c1, no problem. Okay. So, if it is y is equal to mx plus c, for a circle, we are discussing circle here. C square is equal to a square into 1 plus m square. C square equal to a square into 1 plus m square, and the tangent is taken to be y is equal to mx plus r minus a root 1 plus m square. See what I am doing. I am extending it to parabola, please. I am extending it to the ellipse now. See what happens. C square will be same, and a square m square will be same. Second a square becomes b square for an ellipse. Second a square becomes b square. Because if this is a circle now, If you compress the circle, ellipse will be formed. This is a circle, and if you compress the circle, ellipse will be formed. That's what you have to understand. So that's the reason why whatever the conditions are there for a circle, whatever the conditions are there for a circle, they can be straight away transformed to ellipse and thereby to parabola, thereby to hyperbola, thereby to hyperbola. What is that you have to do? Replace second a square with b square. That's it. What does it mean by second a square by b square? If the circle equation is x square plus y square equal to a square, it can be written as x square by a square plus y square by a square equal to what? That second a square replaced with b. Then what happens? X square by a square plus y square and b square equal to 1 is the ellipse. Now, this is how this can be written, then y is equal to mx plus or minus root over a square m square plus b square. And if it is a hyperbola, what happens? This is replace b square with minus b square, c square equal to a square m square minus b square. And thereby the standard form is y is equal to mx plus or minus root over a square m square minus b square. If it is the parabola, it differs. It differs because parabola is not a closed curve. Parabola is not a closed curve. But circle is a closed curve, and ellipse closed curve, and hyperbola has, of course, not a closed curve, but it has two curves. It has two curves. That is the reason why the uniformity will not be there for the parabola. And hence, here it is C is equal to A by M. Condition for this line to touch the parabola y square equal to 4ax. And the tangent will be y is equal to mx plus a by m. But very important point now, what I am going to discuss with you, why I wrote all of them. Just let me minimize this first. Let me minimize this. See here. Why I wrote all of them, See, whenever this line is in the form of y is equal to mx plus c, and the curve is in the standard form x square plus y square equal to a square. Circle and parabola is y square equal to 4ax, and ellipse is x square by a square plus y square b square equal to 1, and the hyperbola is x square by a square minus y square by b square equal to 1. All these conditions holds good. Even if it is x square is equal to 4ay, you cannot apply this. If y square equal to 4x changes to be x square equal to 4ay, you cannot apply this. Then it will be c is equal to minus am square. How many such conditions you remember? How many such conditions you remember? That is the reason why, if you observe the previous questions, rarely these conditions are used in the previous questions. Maybe these conditions, because our MSET is based on memory-based questions will be there more. Maybe in MSET these conditions are used, but if you see the previous JEE questions, down the line 10 years, rarely you get this type of questions that are using this. But you must know a universal condition. You must know a universal method. What I mean to say by universal method, whatever the method I am applying, that should be suitable for circle, that should be suitable for parabola, that should be suitable for ellipse, that should be suitable for hyperbola. For all of them, it should be common. It should be common. So, what is that to be done there? What is that to be done? I will derive a simple derivation, but it can be extended to all just for you to understand the method. See, for example, I have taken whatever the curve you take, no problem. This method can be applied to any curve of any form. I have taken a parabola x square is equal to 4ay, and I have taken a line y is equal to mx plus c. I have forgotten the condition. What is the condition? C is equal to minus am square. C is equal to minus AM square. I forgot it. Like that, how many conditions you remember? That's the reason why most generally in the advanced level questions or JEE main level questions will be following a universal method, because if you see CBSE curriculum, because JEE is based on CBSE curriculum only. If you see CBSE curriculum, very less memory based questions. Less memory based questions, and most of them are conceptual questions. So what is a concept that is to be followed to find out the condition for tangency? See, this is a curve, this is a line. Now what I'm doing, I see whatever the curve it is, I see the line in three different forms. Number one, it is not intersecting. Number two, it is touching. Number three, it is intersecting. The line will be in any one of these three positions. The line will be in any one of these three positions. So what I need is, I need the line to touch. I need the line to touch. So let me do like this. What I'm doing, even though it is not intersecting, what I'm doing, I'm replacing y here. X square is equal to 4a into mx plus c. Implies x square minus 4a mx minus 4ac is equal to 0. Just see that. What is that I did? I eliminated y. What is that I did? I eliminated y. Now, after eliminating y, the algebra is involved here. What is algebra here? Power of x is 2. How many roots a quadratic equation has? How many roots a quadratic equation has? If I ask this question in the class, many times I ask this question, students say there are 2 roots. There are 2 roots. But you will have maximum of 2 roots. You must use that. For a quadratic equation, you will have maximum of 2 roots. For a cubic equation, you will have maximum of 3 roots. For a nth degree polynomial equation, you will have maximum of n roots. Remember that. Maximum of n roots. Why is it so? For example, there is a quadratic equation like this: x square minus 2x plus 1 equal to 0. X square minus 2x plus 1 equal to 0. And how it can be written? X minus 1 whole square equal to 0. Then what is the value of x there? 1. That means here the roots are equal. 1 comma 1. Then what is that happening? As you said, as you think, or so the people are saying, generally the students are saying that there are 2 roots. What happens in this case? It is becoming only 1 root because the roots may be equal also. So that is the reason why it has maximum of 2 roots. This is very much useful here. If it is maximum of 2 roots, it is this case number 3. Because 2 roots are there. Maximum of 2 roots, then this, if it has 2 real roots, this is case number 3. If it has equal roots, it is tangential case. If it has no real roots, it never intersects. If it has no real roots, it never intersects. This is what you have to understand. So that depends on the discriminant. If b square minus 4ac greater than 0, 2 real roots, then the line intersects the curve. If b square minus 4ac is equal to 0, then the line touches the curve. If b square minus 4ac less than 0, no real roots, that means the line will never intersect the curve. So, what is discriminant here? I'm writing it as D, discriminant. Everyone knows that. B square minus 4ac, minus or minus? This is discriminant, please. So, what is that? You get 16 common, of course. The line, case number 1, please. Case number 1. This is 1. Your 1 implies your discriminant is less than 0. 2 implies your discriminant is equal to 0. 3 implies your discriminant is greater than 0. See, discriminant less than 0, discriminant is equal to 0. Generally, we take this only. Generally, we take that only. And because we never follow the universal methods, we always habituate to remember, to memorize the results. Of course, If our memory is good, particularly Indians' memory is very good. That is why we are recognized worldwide. But after by hearting a formula or after remembering a formula, you should not forget the base or the derivation of it. If the question is twisted, then that formula may not be useful. So that's the reason why I'm telling you the derivation here. So what happens? This is equal to 0. What happens then? AM square is equal to minus A square M square is equal to minus AC. AA getting cancelled. Implies C is equal to minus AM square. Remember that. C is equal to minus AM square. The other two cases can also be comfortably written there. The other two cases can also be comfortably written there. It is greater than 0. It is greater than 0 and it is less than 0. So this can be applied to any curve of any form, any line of any form. Remember that. This is the universal method. Generally, the questions will be conceptual like that. The questions will be conceptual like that in the JEE examinations, in the JEE, IIT JEE examination, particularly in the advanced level examinations. Okay, so this is what the concept I want to discuss. And of course, S1 equal to 0 is already there, but this is also an important point to remember. S1 equal to 0 is to be applied only when S1 equal to 0 is to be applied only when the point lies on the curve. Only when the point lies on the curve. So let me take such a problem now. Let me take such a problem where the point is not lying on the curve. Simple question only I'll take. Simple question just to make you understand that. For example, I have taken a circle equation x square plus y square equal to 25. Now I have taken a point which is 7, 2. Just for example's sake. Now how do you recognize whether 7, 2 is lying inside the circle or outside the circle? S11. If S11 greater than 0, point lies outside. If S11 is equal to 0, point lies on. If S11 less than 0, point lies inside. It is common for circle, parabola, ellipse, except for the hyperbola. Except for the hyperbola. The reason is, when you see a hyperbola, you may be thinking that this is the area inside. This is the included part of the hyperbola, but it is external part. It is external part. This is internal part. This is internal part. Remember that. This is internal part, this is external part. That's the reason why only for the hyperbola it differs. What is that difference? S11 greater than 0, point lies outside for a circle, for a parabola, for an ellipse. But for the hyperbola, it lies inside. For a hyperbola, it lies inside. So that's only the reverse. That condition reverses in hyperbola. S11 is equal to 0 is common. The point lies on the curve. S11 less than 0, point lies inside the curve. Circle, parabola, ellipse, inside. But for the hyperbola, S11 less than 0, point lies outside. Point lies outside. Only, you remember that only. You must remember that the difference of the hyperbola. Okay. Now, here I have chosen the question in such a way that the point lies outside. 7 square plus 4, 49, 53 minus 25, positive. I am getting S11, I am getting positive. And hence I have taken the point as 7, 2. Now, what is my intention is, I want to find the equation of the tangent drawn to the circle from this point. From this point, remember that. From this point. That means, when the point lies outside, you should not apply S1 equal to 0. Wrong, please. It is wrong. S1 equal to 0 is to be applied only when the point lies on the curve, and if you go through the calculus applications of derivative, tangents and normals is a topic in which you used to find out dy by dx at a particular point. Dy by dx at a particular point means where does that point lies? That point must lie on the curve. If the point is lying outside the curve, then the first derivative at that point will not give you the slope. So very important point. The first derivative of any curve gives you the slope of the curve. For example, if you take this curve, if you find out dy by dx, it is 2x plus 2y dy by dx equal to 0. Then what is dy by dx? It is minus x by y. Minus x by y. What is that minus x by y? It is a general slope of the curve. What does it mean by general slope of the curve? If dy by dx is consisting of x term, y terms, then it represents the slope of every point and any point on the curve. If dy by dx is consisting of x terms, only x terms or only y terms or both the terms, then you have to understand that dy by dx represents the slope of that curve, which is a general slope of the curve, which represents the slope of every point and any point in the curve. Every point, circle is there. Every point and any point on the curve. It represents every point and any point on the curve. Then you pick up one point on the curve and substitute in dy by dx. Pick up one point on the curve and substitute dy by dx. Then you will get the slope of the curve at that particular point. Then you will get the slope of the curve at that particular point. That is the point I want to insist. Now, if this point is lying outside, I am interested in this tangent. I am interested in this tangent. So, to find out the equation of the tangent, you can now make use of that condition. Y is equal to mx plus or minus root over a square m square plus a square. So, this is y is equal to mx plus or minus root over a square is 25 m square plus a square 25. So, but it passes through 7 too. So, 2 is equal to 7m plus or minus root over 25m square plus 25, square it, 2 minus 7m, 14, I'm squaring it please, squaring it, minus 28m is equal to 25m square plus 25. So, what is the final curve? What is the final equation you get? 49 minus 25, 24m square minus 28m plus 25, that side 4, minus 21 equal to 0. By solving this, you will get the value of m. And thereby, if you substitute that m in this one, you will get the required tangent, and those tangents will be obviously from an external point. Two tangents can be drawn to a circle. Parabola, ellipse, or hyperbola. Two tangents can be drawn from an external point to a circle. This is a method I want to insist upon. S1 equal to 0, usage of S1 equal to 0 may be misunderstood. That is why I have taken this for the revision sake. Okay, now, next question please. See that? The locus of the centers of the circle which touch the circle x square plus y square equal to 1 externally also touch the y-axis and lie in the first quadrant. Question is simple, but in geometry what happens? Understanding the question and converting it to algebra is important. Here, in this case, what is saying, and in my previous sessions, I am insisting upon the locus problems. Whenever you come across locus problems, always start the problem by taking whatever the point is there after locus of. I repeat this. Wherever you solve the locus problems, whatever the point is there after the locus of, take that point as x0, y0. What is that point there? The locus of the centers of the circle. So let center be x0, y0. That's what I did. Let center be x0, y0. Okay. Now, which touch the circle x square plus y square equal to 1? Externally, this is the circle given. Another circle is touching this. When it is touching externally, you know C1, C2 is equal to R1 plus R2. What is C1 here? This is, let me say this as C1. What is C2? 0. I'm writing it here. This is x0, y0. This is 0, 0. And its radius is 1. Its radius, we don't know. Let it be R. So for that, he gave the extension because we don't know the radius. An important point I discussed in the previous session is that it also touches y-axis. When a circle touches y-axis, the radius is equal to modulus of x coordinate of the center. I revise it. I revise it. This is the circle, please. This is another circle. This is one of the circles. What are the conditions here? When the circle touches x-axis, if the center is a comma b, then r is equal to mod b. If the center is a comma b, then r is equal to mod a. If the center is a comma b, then radius is equal to center x coordinate is equal to center y coordinate. That won't change. See, why is it not changing? You know, if you roll the circle on x-axis, I repeat, if you roll the circle on x-axis, what is the parameter that's not changing? The side will never change. The side will never change. What is this side? Is nothing but y coordinate. It's nothing but y coordinate. So simple remembrance is like this. When the circle touches x-axis, y coordinate of the center is radius. Of course, modulus is to be taken because it is a distance. When the circle is touching y-axis, radius is equal to modulus of x coordinate. X-axis it is touching, radius is y coordinate. Y-axis it is touching, radius is x coordinate. In this case, the question is, it is touching y-axis and hence your r is nothing but x0. See how the problem is splitting now. Your r is x0. Now what is the condition if they touch each other externally? C1, C2 is equal to R1 plus R2. C1, C2 is equal to R1 plus R2. What is C1, C2 distance between them? X0 square plus Y0 square under root is equal to 1 plus R. Because 1 is the radius and R is the radius of, R means here X0. Correct, no? So let us simplify this now. X0 square plus y0 square is equal to 1 plus x0 square plus 2x0. So x0 getting cancelled implies y square is equal to 1 plus 2x should be the answer. Y square is equal to 1 plus 2x should be the answer. So it is option A. He gave the square root of it. So see the concept here. C1 CT is equal to R1 plus R2 when the circles touch each other externally. C1 CT is greater than R1 plus R2 when the circles never intersect each other. When the circle intersect each other, then C1 C2 less than R1 plus R2. I explained it in the previous session. When the two circles are touching each other internally, externally means like this, internally means like this. When they touch each other internally, C1 C2 is equal to modulus of R1 minus R2. If one circle is lying inside the other, C1 C2 less than modulus of R1 minus R2. If one circle has a center same as the center of the other circle, then they are said to be concentric circles. They are said to be concentric circles. Okay, so this question is also important. Immediately you have to get these ideas. It's not that easy unless you practice. Let us go through the next question, please. Next question. The line x equal to y touches a circle at the point 1, 1. If the circle also passes to the point 1, -3, then its radius is. See, do you observe the questions here? This is latest question only. Is not the questions, if you observe properly, is not using the memory-based questions. Memory-based questions, what I mean to say, the equation of the tangent in the slope form. Equation of the tangent in the slope form is just now I erased it. Y is equal to mx plus or minus root over a square m square plus a square. It's not using. It's using the questions. Generally, what happens when JEE, IIT JEE, advanced examination, never the question repeats. Whatever the question paper is set, all are new questions only. But why to work out the previous papers? Previous papers are confidence boosters. Previous papers, if you are successfully answering, that will boost your confidence levels. But unlike advanced examination, JEE main examination, if you take, you have, I'm repeating that. In the previous session also I said, you will get for a compulsory question topic, you will get minimum of 20 questions. If you collect 19, 20 or 18, 19, 20, minimum of 20 questions you'll get. If you work out all those 20 questions, every concept will be revised. So don't miss out any question and observe how the questions are formed. Here, direct, the question is not direct here. Question is not direct. Indirectly it is given. A circle is touching. A circle, see the question there. If the line x equal to y, everyone knows it is the angular bisector of the coordinate axis. X equal to y touches a circle at the point 1, 1. And what else? 1, 1, if the circle also passes through 1, -3. Some area. 1, -3. It touches here and passes through this. Like this it is. What is the point here? 1, 1. And also passes through 1, -3. Then its radius is. See, you have to find out the radius of this. What is the data given? Only one line given, x equal to y, and the point given. Point of contact is given 1, 1, 1. Sai Varshit is saying option D, not 2. Option 2. Let me check. Now, what is to be done here? This is a tangent. This is a circle, please. That's what I discussed in the beginning. It's a point circle. This is a system. Let us form a system. This is one circle. This is another circle. This forms a system whose common tangent is this. Okay. Now I'm writing the equation of the circle x minus 1 whole square plus y minus 1 whole square is equal to 0 because it is a point circle. Okay. Now, what is the line equation or tangent equation? X equal to y, it is given. So, this is equal to 0 is the circle. Therefore, I am writing s plus lambda L equal to 0 implies x square plus y square minus 2x minus 2y plus 2 plus lambda into x minus y equal to 0. But this forms a system of circles for different values of lambda, but I need that circle which passes through 1, -3. I need that circle which passes through 1 comma minus 2. Substitute here, 1 plus 9, 10, 10 minus 2, 8, 8 plus 6, 14, 14 plus 2, 16 plus lambda into x minus y, 4 implies lambda is equal to minus 4. Substitute that here. Substitute that lambda here. Then what is the equation of the circle you will get? The equation of the circle is nothing but x square plus y square minus 2x minus 2y plus 2 minus 4 into x minus y equal to 0. Minus 4 into x minus y is equal to 0. Then what happened? It is x square plus y square minus 6x minus 2y plus 4y plus 2y plus 2 equal to 0. Radius is equal to root over g square plus f square minus c. It is 2 root 2 units. Sai said that it is 2 units. I got 2 root 2. Let me check. So option B is the answer. No, he did not say anything. I was seeing the previous chat. See what I'm saying, it's not that easy question. The concept, how he used the system of circles. Everywhere in the problem, he is using the system of circles. Be thorough in the system of circles. How the concept of system of circles is used in different problems. Be more clarity about the system of circles. Okay, now the next question. I have taken 2 questions here. I'm displaying the first question. 2 circles with equal radii are intersecting at the points 0, 1 and 0, minus 1. The tangent at the point 0, 1 to one of the circles passes through the center of the other circle. Then the distance between the centers of these circles is. See the level of the question there. Immediately, what are the concepts that we have to remember after going through the question? 2 circles are there. They are intersecting at 0, 1 and 0, minus 1. First point of intersection 0, 1. Below point of intersection 0, minus 1. So what is that you have to understand? X is equal to 0 is that. See, in both the points x equal to 0. X equal to 0 is the equation of y-axis. And thereby you have to understand. That the line of centers is nothing but x-axis. That means, because we don't know the centers there, let us take one center as alpha comma 0, other center as minus alpha comma 0. Then can we take like that? Yes, you can, because it is given that their radii are equal. That means equal circles. Circle sizes are equal. I'll draw the diagram. I'm discussing just for you to work out the problem. You just try it. After me explaining the concept, you try it. So these 2 circles are intersecting. One is 0, 1, other one is minus 1, 0. Then the line of centers will be passing through 0, 0. Which is nothing but x-axis. On x-axis, take the first circle center as alpha comma 0, second circle center as minus alpha comma 0. Whatever. In either of the ways also it goes. After taking the centers, the very important point, the property what he used in that question, just see that. one of the circles passes through the center of the other circle. One of the circle passes through the center of the other circle. It is possible only when the two circles cut each other orthogonally. Very, very important. It is possible only when the two circles cut each other orthogonally. When the two circles are cutting each other orthogonally, you have the conditions. You have the condition 2G1, G2 plus 2F1, F2 is equal to C1 plus C2. One condition. Otherwise, D square equal to R1 square plus R2 square. D square is equal to R1 square plus R2 square. At this juncture, let us revise the angle between two circles. Angle between two circles formula cos theta is equal to D square minus R1 square minus R2 square divided by 2 R1 R2. If theta becomes 90, this condition you will get. What is the condition? D square equal to R1 square plus R2 square. What is D square? Distance between the centers. So indirectly he mentioned that the tangent to one of the circles is passing through the center of the other. So you understand that there are, if you analyze the question, there are, the common chord is nothing but y-axis, the line of centers is nothing but x-axis, the common chord is nothing but y-axis, the line of centers is nothing but x-axis, and these two circles are intersecting each other at right angles. These two circles are intersecting each other at right angles, and he gave that the circles are equal. Equal circles. Equal circles means the radius are equal. The size of the circles is same. So let us see that. Let us see that now. Let me draw the diagram. This is the first circle. This is the second circle. Of course, the size may be little bigger. I'm not a good artist. So adjust. Remember the concept. Remember the data given in the question. The two circles must be of the same size. This is the point 0,1 above. This is the point 0 minus 1 below. And these two lines, that is a common chord, is nothing but y-axis, because I know x equal to 0 there. And obviously the line of centers. Becomes x-axis. And if I take this center as some alpha comma 0, then this is lying on the other side, C2 minus alpha comma 0. Then you may be thinking, sir, how can we take that? If it is alpha 0, how can you say that is minus alpha comma 0? Because the size of the circles is same. And also given that the tangent drawn at one point passes through the center of the other. If you draw the tangent here, it passes through the center of this. If you draw the tangent here, this passes through the center of the second cycle. What does it mean? Indirectly, it is given that they are intersecting orthogonally. So now this is the radius. How we used it? Just see that. It is alpha square plus 1 under root. Just see that. It is also alpha square plus 1 under root. Are you with me? How we took it, we have seen in the question that the two circles have the same radius. That is why I took the same radius. Okay, now let me write this circle. X minus alpha whole square plus y square is equal to alpha square plus 1 implies x square minus 2 alpha x. Let me write the circle form, standard form. X square plus y square minus 2 alpha x. Alpha square getting cancelled, minus 1 equal to 0. This is first circle. Second circle, this is circle 1. Second circle, x plus alpha whole square means x square plus y square plus 2 alpha x minus 1 equal to 0. Now 1 and 2 are cutting each other orthogonally. 1 and 2 are cutting each other orthogonally. See, 1 and 2 are cutting each other orthogonally means apply 2g1 g2 plus 2f1ft is equal to 0. Then thereby you will get alpha value. Thereby you will get alpha value. Okay. So 1 is perpendicular to 2. Apply 2g1 g2 plus 2f1 f2 is equal to c1 plus c2, or one more condition, d square is equal to r1 square plus r2 square. D square means distance between the centers. Both can be applied, no problem. Both can be applied, no problem. Whatever is comfortable, you apply that. What is d square? Distance between the centers is 2 alpha here. Distance between the centers is 2 alpha here. What is r1? What is r1? Root over alpha square plus 1. Root over alpha square plus 1. So, both radii we know. Both radii we know. We know the distance between the centers, and thereby you will get the value of alpha. After getting the value of alpha, what is the question given? You have to find out the distance between the centers, 2 alpha. So now, I am writing this only. I am using this. I am using this. What is d square? 2 alpha whole square is equal to r1 square plus r2 square, which implies that 4 alpha square minus 2 alpha square. 2 alpha square is equal to 2 alpha is equal to plus or minus 1. Therefore, C1 is equal to 1 comma 0. C2 is equal to minus 1 comma 0. Therefore, C1, C2 is equal to distance between them is nothing but 2. Distance between them is nothing but 2. Let us check. It is option D, please. Option D. Just check it out. Not that easy question, please. It is given in the latest 2019 main examination. Not that easy question. You may have different ideas to work out. You must have. You may have. I should not say you may have. You must have different ideas also to work out such problems. Okay. Now, let me go through the next question, which is below this. Oh, this is also a conceptual question which requires a lot of construction. Lot of construction is required. 3 circles of radii A, B, C, where A is smaller than B is smaller than C, touch each other externally if they have x-axis as a common tangent. Then ABC are in AP. 1 by root A is equal to 1 by root B plus 1 by root C. 1 by root B is equal to 1 by root A plus 1 by root C. See, the question is, see, there are 3 circles given, only the radius is given, that's all. Only the radius of the circles is given. An extra condition given that all these 3 circles are touching each other externally, and the common tangent for all these 3 circles is x-axis. See here, this is x-axis. I have taken a horizontal line, x-axis. Okay, let me minimize this. Whenever necessary, I'll come to that question. Okay. Now, there is a small circle, then a big circle, then still bigger circle. 3 circles of different sizes. Let me say, this is one circle. I have to construct bigger. I have to construct bigger here. because to have the clarity, this is one circle, this is another circle. All are touching x-axis. This is a smaller circle. See that please? Smaller circle. Smaller circle radius is given to be A, and the bigger circle radius is given to be C, and the in between the circle is given to the radius of the circle is given to be B. This is A, this is B, this is C. So now, when these two are touching each other externally, this is B, this is A. When these two are touching externally, this is C. When these two are touching externally, that is B, this is C. See the construction there. Okay. Now I can say, I'll name them. This is A, let me say. I'll name it. Giving this type of questions in JEE may really cruel. The time is less. If it is given in the advance, we have to accept. The talented students will be answering it easily. But to have the construction itself, it takes a lot of time. See how much time I'll take to explain this. Of course, the explanation is different, but you have to get the instant idea while answering the questions. Now, this is A, this is B, this is C. Now, this is small a again. And this is small b. And this is small a, you know. Then this length will be b minus a. Just check it out. This total length is b, this length is a, and this length is b minus a. Similarly, this length is c. Okay, and this length is nothing but, just check it out. This total C, this is B. This is total C, this is B. This is C minus B. See that please. C minus B. And similarly, if you extend this, this is totally C, this is A. This is totally C, this is A. Then this becomes C minus A. Then see that please. This is right angles. Now what happens? What happens here? This is B plus A. Hypotenuse B plus A. Let me name this P, Q, A, B, C, I don't know. This is nothing but A. This is nothing but Q. Now PQ is equal to PA plus AQ. Keep it like that. PA plus AQ. Now If you take PQ here, it is nothing but, let me write PA now. PA. What is PA, please? This one, PA is equal to, PA square is equal to, this is a right angle triangle, you know, this hypotenuse B plus A whole square, and it is B minus A whole square, which is nothing but 4AB. So you got PA is equal to 2 root AB. PA is nothing but 2 root AB. Similarly, AQ, please. AQ square is equal to, this is nothing but A plus C. A plus C whole square minus of C minus A whole square is nothing but 4AC, implies AQ is equal to 2 root AC. AQ is equal to 2 root AC. See this one. We got it. Now I need PQ here. PQ is nothing but, let me say, this is R. PQ is equal to BR. Implies PQ is equal to, let me say PQ square here. PQ is equal to BR. PQ square is nothing but BR square. What is BR square here? BR square, this one. This entire length is nothing but B plus C. So B plus C whole square minus of, this one please, C minus B whole square, which is nothing but 4BC, implies PQ is equal to 2 root BC. Substitute in this one. 1 implies 2 root BC is equal to PA, 2 root AB plus 2 root AC. These two getting cancelled. Now, according to the condition given, you have to check it out. According to the condition given, you have to check it out. Let us check the conditions now. These are the conditions given. 1 by root A, root will be there compulsory. A, B, C are not in AP, there is no doubt. And B is 1 by root A is equal to 1 by root B plus 1 by root C. Maybe we have to divide with root ABC. Then what is that you get? 1 by root A is equal to 1 by root C plus 1 by root B. So B option. Option B, please. See the length of the question. See the length of the question there. If you come across this type of questions now, you attend them at the end. And if you get ideas instantly, that will be good. That will be good. But this question is totally depending on the construction. See, what are the properties that we use for a circle? Just revise it. What are the properties that we used for a circle? We have used only when the circles are touching each other externally, the distance between the centers is equal to sum of the radii. That's what that is only the property we used here. Based on that property, and rest all are construction based. Otherwise, we don't get idea. Even myself also, I have seen the solution, I explained you. I did not get the idea. I have seen the solution. Okay. Now, the next question, please. Yes. See this one, 2016, previous question. The centers of those circles which touch the circle x square plus y square minus 8x minus 8y minus 4 equal to 0 externally and also touch the x-axis. It is very much similar to a previous question. Just we have taken one such question which touches the circle externally and touches y-axis we have taken there. Touches y-axis. Here touches x-axis. When it touches x-axis, you know what happens? The radius of the circle, is nothing but y coordinate of the center. Touching x-axis, radius is y coordinate of the center. Touching y-axis, radius is x coordinate of the center. Just reverse of it. Reverse. X-axis touching y coordinate, y-axis touching x coordinate. So this question now is how to start the question. It is nothing but the locus only, because if you see the options, it is a circle, an ellipse, which is not a circle, a hyperbola, a parabola, like that it is given. The centers of those circles, you have to take the center as x naught, y naught. Let center C is equal to x naught, y naught. Whose center? The locus. It is a point on the locus. Whose locus it is? The centers of those circles. Center of the circle is x naught, y naught I have taken. Now, whenever you write this, immediately you have to write that its radius is modulus of y naught. If you write that, the problem is solved. If you write that, the problem is solved. Okay. Now, radius is mod y naught, center is x naught, y naught. So everything is known to us. Center we know, radius we know. You can write the equation of the circle. But what is the circle given there? X square plus y square minus 8x minus 8y minus 4 equal to 0. Okay. Now center is equal to 4 comma 4. Radius is equal to 16 plus 16. 32 plus 4. It is 36. Under root 36 it is 6. Radius is 6. When the circle is touching externally, C1, C2 must be equal to R1 plus R2. This is R1, this is R2, this is C1, this is C2. C1, C2 is equal to R1 plus R2. What is C1, C2 here? C1, C2, x naught minus 4 whole square. I can write directly x. I am removing x naught. X minus 4 whole square plus y minus 4 whole square is equal to R1. It is under root place. It is under root. Is equal to R1 is mod y naught plus mod y plus 6. R1 plus R2. R1 plus R2 please. Now this is to be simplified. Sir, Ram Subbareddy, tangency condition we can do. Oh, okay, the previous one. Okay. Now, this is to be simplified. You have to square on both sides. You have to square on both sides, but whenever the modulus is there, there is every chance of getting two answers. If it is advanced examination, definitely you will have two options there. Because y may be positive or y may be negative, but nothing is given there. Nothing is given about y. So you will get two answers for this. whatever the answer it is, but he is asking only for the shape of the locus. He is asking only for the shape of the locus, but not the equation. So let us simplify this. X square plus y square minus 8x minus 8y plus 32 is equal to y plus 6 whole square, y square plus 12y plus 36 if y greater than 0. That's what you have to understand. Y greater than 0 means modulus can be removed directly. I have taken that first. Now let us check it out. Y square getting cancelled, and it is x square is equal to, it is 8x plus 20y plus 4 is a parabola. Is a parabola, please. It is a parabola. Just check. Check the method. It is very much similar to the previous question only. I'm sorry, I did not observe this. What is that? Distance between the centers is equal to sum of the radii. Distance between the centers is equal to sum of the radii. We apply that, and thereby whatever the final equation we have got, it is in the form of x square is equal to y power is 1, x power is 2, and hence it becomes a parabola. So the option for that one is option D. It is option D, please. And you may be thinking like this, sir, if it is y is less than 0, what happens? That becomes minus y plus 6 whole square. Minus y plus 6 whole square means y square minus 12y you get. Y square minus 12y plus 36 you get. Then minus 12y here, it becomes minus, if it is minus 12y, what happens? This will come this side, minus 12y plus 8y, you'll get minus 4y. Other locus is, if it is minus 12y plus 8y, minus 4y. And constant will be same. See the difference between these two. This is parabola, this is also parabola, but the answers are different. So, more than one correct answer questions, there is every chance of asking this type of questions, because generally we neglect this modulus. As many times as we say to the students generally that modulus is neglected. So whenever modulus is neglected, generally in the board level examination or sometimes in the JEE also, maybe it may go, but in the advanced level examination, you must have the conceptual understanding very clearly. So you'll get two answers for this one. Okay, now coming to the next one. This I have taken, this is an advanced question, please. This is an advanced question. Integer type. Nowadays, the JEE main also, they're asking for integer type questions. I have taken. I don't think that integer type standard of JEE advanced, may not be equal to the integer type question standard of JEE main. May not be. So see this question now, for how many values of P the circle and the coordinate axis have exactly 3 common points. Circle is very simple. Circle is given to be simple there. Simple circle given, which is x square plus y square plus 2x plus 4y minus b. Understanding such questions itself is difficult sometimes. What he means to say, he's saying that For how many values of P? The circle and the coordinate axis have exactly 3 common points. Exactly 3 common points. See, let us assume different cases. Let us assume different cases here. So, if 3 common points must be there, it may be like this. It may be like this. One, two, three. That means it is possible whenever it passes through origin. That means it is possible whenever it passes through the origin. When it passes through the origin, obviously there will be no constant. P is 0. Not only that, what should be the other case? The circle is touching x-axis and intersecting y-axis. It may be like this. Or the circle is touching y-axis and intersecting x-axis. These are the 3 different cases. It's possible whenever 3 common points will be there. 1, 2, 3. 1, 2, 3. Okay. Now it is, because it is an advanced level question, how algebraically it is to be checked out. You must remember the x-intercept made by the circle. What is x-intercept made by the circle? 2 root over g square minus e. X-intercept 2 root over f square minus c. Y-intercept see, because it is present under the root, there are many restrictions. Now we can leave this question because data we have already taken. 1, 2, 3, 1, 2, 3, 1, 2, 3. This is decided. P is 0, but here it is to be decided whether this is possible or this is possible or both are possible. Then if both are possible, this is plus 1. There will be 3 values for P. If only one is possible, there will be 2 values for P. Okay. Now, when it is 2 root g square minus c, it is 2 root f square minus c. It is touching x-axis. Touching x-axis means your g square is equal to c. And your f square minus c, 2 real roots it must have. F square minus c must be greater than 0. Just observe that. It touches, g square equal to c. It intersects y-axis, then f square must be greater than c. What is g square then? What is g square? G square is 1. It is equal to c means minus p. And what is f square then? P value is minus 1. What is f square then? F square is 4. What is c? C is, in this case, c means here, p, minus 1. What is c? What is minus p? 1. So 4 greater than 1. It is very much possible. It is very much possible. Let's go to the next one. Now, by now, you must have understood. How to check this. In this case, 2 real roots on x-axis. That means your g square must be greater than c and f square must be equal to c. What is g square here? What is g square in this case? G square is 1. What is f square here? Let us check. This is done. Let us find out f square first. What is f square? 4. What is C? Minus P. So what is the value of P? Minus 4. What is the value of P? Minus 4. What is G square there? 1. What is C there? Minus P value 4. 1 is greater than 4, which is not possible. 1 is greater than 4, which is not possible. So for this circle, for different values of P, there are only 2 such conditions will be there. Number 1, it passes through origin. Number 2, it touches x-axis and intersects y-axis. It intersects x-axis and touching y-axis is not at all possible. For no value of P it happens, because you got 1 is greater than 4, and hence answer for this question is 2. So integer type question, no, you will have only one answer. It is 2, please. It is 2. Okay. So these are some previous questions I have taken, and we will be continuing in the next session by taking conic sections. And conic sections means you will have mixed questions. You will have mixed questions that are there, that will be using the circles, parabola, ellipse, and hyperbola. I will be taking up the mixed questions, and so that I'll be revising all the linked concepts of coordinate geometry. What I mean to say by linked concepts of coordinate geometry, if you understand circles concept properly and the formulae properly, every such concept can be extended to ellipse and hyperbola, and rather even for parabola also. For example, in a circle, if you take the director circle, what is a director circle? What is the definition of director circle? It is the locus of, point of intersection of perpendicular tangents drawn to a circle. It is the locus of point of intersection of perpendicular tangents drawn to a circle. That locus is nothing but the director circle. In case of a circle, the director circle equation for a circle, x square plus y square equal to a square, is nothing but x square plus y square is equal to 2a square. The equation of the director circle to a circle, x square plus y square is equal to a square, is nothing but x square plus y square equal to 2a square. If you want to extend it to ellipse and hyperbola, what is that we do? That 2a square will be split as a square plus a square. The 2a square will be split as a square plus a square. Second a square replaced with b. Second a square replaced with b square. Then thereby the director circle to the ellipse, x square by a square plus y square by b square equal to 1 is nothing but x square plus y square is equal to a square plus b square. If you want to extend it to hyperbola, you know, hyperbola, what is it? X square plus y square is equal to a square minus b square. In the ellipse, wherever you have b square, replace b square with minus b square. So how it is extended? See that. You may be under the impression that the concepts of circle is different, the concepts of ellipse, hyperbola, parabola are different. No, not at all. The definitions are uniform, and hence what all the formulae are, that they can be straight away extended. Then in that case you may be thinking like this, what about parabola? What about parabola? Parabola is not a closed curve. That is why these conditions cannot be extended. But the definition is one and the same. Definition is one and the same. How? You know? What is the definition of director circle? The locus of point of intersection of perpendicular tangents drawn to a curve. Here the parabola is also a curve. The locus of point of intersection of perpendicular tangents drawn to the parabola. Here, in a circle, ellipse and hyperbola, that is said to be director circle. In a parabola, it is nothing but the directrix. In a parabola, it is nothing but the directrix. See, parabola has many more conditions, many more properties. Among all the conic sections, parabola will have many more properties and conditions. How it becomes directrix? Take any point on the directrix of the parabola, and if you draw two tangents to the parabola from a point on the directrix, those tangents will always be perpendicular to each other. Those tangents will always be perpendicular to each other. Let me remind you that. If you take the equation of the tangent at T1 to the parabola, if you take the equation of the tangent at T1 to the parabola, it is nothing but YT1 minus x into minus x minus 81 square equal to 0. Equation of the tangent at T1 to the parabola, standard form, y square equal to 4ax. It's nothing but YT1 minus x minus 2a 81 square is equal to 0. Similarly at T2 also same. If you solve them now, if you solve the tangents drawn at T1 and T2 to the parabola, the point of intersection you get is a T1 T2 comma a into T1 plus T2. A T1 T2 comma a into T1 plus T2. But if the tangents are perpendicular to each other, T1 T2 is equal to minus 1, and in this point of intersection, if you substitute x is equal to a T1 T2, replace T1 T2 with minus 1, then x is equal to minus a. X equal to minus a is nothing but x plus a equal to 0. So x plus a is equal to 0 is nothing but the directrix. So whatever the point you take on the directrix, if you draw the tangents through a parabola, then those two tangents will always be mutually perpendicular to each other. We will be continuing the session, tomorrow's session, or maybe day after tomorrow's session. I'll see that whether it happens tomorrow or not. And this will be continuing with all the concepts together of the coordinate geometry by taking the previous questions. Around the question only, I'll be discussing all the concepts. See you in the next session, and Shubhratri. Good night. Namaste.